Hello and welcome to ICND2 Lab 8, IP version 6 subnetting and address configuration. If you're using the Cisco Press exam certification guides, note that the material covered in this particular video is also covered in the ICND2 books, Chapter 17. This lab has three main objectives. By viewing this lab, you should be better able to describe the format of a type of IPv6 address called IPv6 Global Unicast addresses. You should also be better able to describe the similarities between IP version 4 and IP version 6 subnetting. Finally, you'll learn how to configure IP version 6 addresses on Cisco router interfaces. This lab uses two main scenario steps to achieve these objectives. The first part of the lab compares IP version 4 subnetting to IP version 6 subnetting using a simple internetwork with two routers. The second step will configure full 128-bit long IP version 6 addresses on a couple of router interfaces. So let's begin scenario step 1 by examining the IP version 4 details of a very small internetwork. In this network, the network engineer wanted to use public registered IP addresses, and they obtained a Class B network. Now, it's unlikely you'd get a Class B network today for such a small internetwork. However, just to make some points with IP version 6, we'll use Class B network 128.107. The network engineer needs to subnet that network, of course, so he's chosen to use a /24 prefix length, in other words, a mask of 255.255.255.0. So simple enough. Now, in this case, we'll need three subnets, including a subnet on the far left LAN. So the engineer has chosen to use subnet 128.107.11.0 with that /24 mask. Now, of course, we're not going to say it that way usually when we're speaking about it. We'll probably just call this subnet 11 because the third octet is the subnet field in this case. Similarly, we need a subnet for the serial link. So in this case, the engineer has chosen subnet 128.107.112.0, but we're probably going to call that subnet 112. Finally, we need a LAN subnet on the right, so the engineer has chosen subnet 12 for the subnet on the right. Now let's take a lot closer look at the subnet on the left, subnet 11, because by closely examining a few facts and then comparing that to IP version 6, you can see how IP version 4 and IP version 6 subnetting are actually very similar at a basic conceptual level. So here we've got subnet 128.107.11.0, and we know that the first two octets in this case are the network part of that number. That's because of Class A, B, and C rules. We also know that we're using that network for all subnets in the internetwork of two routers and two LANs that we saw a few seconds ago. So all addresses in that internetwork will begin with the network part of 128.107. Then, of course, we've got a subnet field that in this case is the whole third octet, subnet 11 in this case. And we know that now, for all addresses in that one LAN subnet on the left of this internetwork, that all addresses will begin with the same combined network and subnet part of 128.107.11. Now, we denote the fact that it's the whole first three octets, or first 24 bits, by putting a slash at the end of the number and listing 24, the number of bits in the combined network and subnet parts of the address. Finally, the one remaining portion of the address is the host part of the address. It's the fourth octet in this particular example. Now, there are a couple of important things to note in this case. For the different addresses on the LAN, the host part needs to be different. That's the way you can tell different hosts apart. Also, for the subnet number itself that's listed here, the host part, or the host ID, is a value of 0. Next, let's compare this IP version 4 subnet to the IP version 6 subnet that I've chosen to use in this video on that same LAN. The IP version 6 subnet number is listed on the screen now. It's obviously a very long number. Of course, IP version 6 addresses are 128 bits long, and they're written as hexadecimal numbers, 4 at a time, separated by colons. I like to call each set of 4 hex digits a quartet, and having 4 hex digits means that it represents 16 bits. So it's rather a long number, but splitting out the details can help us better understand what's inside there. So let's take a look. First of all, the first three quartets, first three sets of 4 digits, is called the ISP prefix in my example. This ISP prefix is indeed assigned to this company by the ISP that they're going to use to connect to the internet, and it's the equivalent of Class B network 128.107. It's the equivalent in that all IP version 6 addresses in this inner network will begin with these first 12 digits. And like Class B network 128.107, the only place in the universe for which the addresses that begin with this ISP prefix exist should be on this particular inner network. Just like with IP version 4, the engineer is now going to choose how to subnet for IP version 6. In this video, I'm going to use the whole next quartet, the next 4 hex digits, or the next 16 bits if you will, as the subnet field. Now with 16 subnet bits, I can create a lot of subnets. So I've got plenty of capacity there for subnets. So all I've really done here is extend the prefix that I was assigned by some numbering authority, so I'll have some bits to number different subnets inside my inner network. And just like with IP version 4 for that LAN subnet on the left, all addresses begin with 128.107.11. Now with IP version 6, all addresses on that left-hand subnet are going to start with 2233:0000:2222:0011, or if you prefer, they'll all be in subnet 11. Next, let's talk about prefix lengths. With IP version 4, the prefix length, which is listed after the slash at the end of the subnet number, is the length of the subnet and network fields put together. Well, similarly, with IP version 6, the prefix length is based on the length of the ISP prefix and the subnet put together. In this case, for instance, we've got a 3 quartet long ISP prefix and a 1 quartet long subnet field for a total of 4 quartets. Of course, that's the same as 16 hex digits or 64 bits. Because the prefix length is written in bits, here at the end of the subnet number in IP version 6, we've got a /64, meaning a 64-bit long prefix. Finally, let's take a look at what happens after the IP version 6 prefix. In IP version 6 terminology, we call this remainder the interface ID, although a lot of people call it the host field or host ID in keeping with IP version 4 terminology. Just like with IP version 4, when writing down a subnet number, the convention is to put zeros in the host or interface ID field, just as we see here. Then, when you want to write down or configure an individual IP version 6 address, you put some value in this 4 quartet field that's unique for each host on that subnet so that they have a unique IP version 6 address. Before moving on to discuss how to configure IP version 6 addresses, it's important to consider how to abbreviate IP version 6 addresses and subnet numbers. For instance, here's the longhand version of the subnet number we've been working with all along in this video. Now there's 3 main rules you can use to abbreviate or shorten this particular IP version 6 subnet number. The first of which is that inside a quartet, you can remove any leading zeros. For instance, the subnet quartet in this case, 0011, can be abbreviated down to simply 11. So that second version of the subnet is indeed a valid abbreviation, but it's not the shortest valid abbreviation. So let's take a look at the second rule that you can use. In a quartet that's all zeros, you can abbreviate it down to a single zero. So if you look at the second quartet here, we can abbreviate that down to a single zero, as you see there in the third version of this same subnet number. So all 3 subnet numbers are equivalent, just the third one is the shortest one so far. There's a third rule that you see here that lets you shorten this subnet number quite a bit. This rule says that if there are multiple consecutive quartets of all zeros, you can represent those multiple quartets simply as 2 colons. In other words, there's nothing in between the colons. So as you see here, we can shorten this subnet number to 2233:0:2222:11, and then 2 colons. With only one such instance in the number, a device can figure out, oh, I'm missing 4 more quartets, so obviously I need 4 quartets of all zeros here. Now the thing that's significant for us is that when we get into the configuration on different devices, and in this video we'll see that on a Cisco router, is that even if you type in an address or a subnet number in the long version like you see in the very first entry, when you do show commands, you'll only be shown the short version of the address. Now you've seen the significant similarities in the concepts behind subnetting in IP version 4 and IP version 6, let's take a look at a few of the particulars that I chose to put in this video so I can demonstrate IP version 6 address configuration on router R1. Now as a reminder, we use subnets 11, 112, and 12 for our earlier IP version 4 example. Now, if I wanted to deploy IP version 6 in this particular internetwork, I might try to keep things simple. So, for the subnet on the left, the IP version 6 subnet, I'll make it subnet 11, if you will, with the prefix that you see there. Then for the serial link, I'll make it subnet 112, just like with IP version 4, with the long prefix that you see there. And finally, on the far right, on the LAN on the right, we'll use subnet 12, with, of course, the long IP version 6 prefix. Now, in this video, I'm going to show how to configure IP addresses on R1. So we know the prefix, but we need to assign an actual IP address. So in this case, I'm going to use an interface ID of all zeros ending in a 1. Now, I might choose a nice, easy interface ID like this in real life so that my router IP addresses are easy to abbreviate and it makes typing in ping commands a little less painful. Now, to form the entire IP version 6 address that needs to be configured on R1, say on its LAN interface FA00, we need to combine the prefix that you see above that LAN with this interface ID that I've chosen to configure. So as you see here in the video, we'll combine those two for this nice long IP version 6 address. Next, let's take a look at the IP version 6 configuration steps on a router. The first step is to use a global command in order to enable IP version 6 on a router. The command is IPv6 unicast-routing. At that point, you can then effectively go and configure IP addresses on the interface with the IPv6 address command. So if you look at the IPv6 address command for a moment, note there's an address parameter, a slash, and then the prefix length. There are no spaces at all in that big long parameter. For instance, here we've got the IPv6 address command that we'll type in on interface FA00 in the video in just a moment. Here first we see the prefix value, but you don't put any spaces yet. You keep going and type the entire IPv6 address, including the interface ID that you see there. Then, again with no spaces, you put a slash, and in this case a 64, because we're using a 64-bit prefix. In the command line interface, I'm going to use this exact IPv6 address command on R1's FA0/0 interface. Now, it turns out the IPv6 address command will accept any version of a valid IPv6 address, both with and without all the abbreviation rules thrown in. Now, I've used a relatively long version of the IPv6 address here, so there's a couple of ways we can abbreviate this address. First, as you see there on the screen, I can abbreviate this set of 3 consecutive all zeros quartets as a colon. That gets quite a bit shorter. However, there's more work to do. If you take a look at the last quartet, which has 3 leading zeros, we can of course abbreviate that down to a single digit, or 1 in this case. So now on the screen at the bottom, you see the shortest version of the IPv6 address that we're going to assign to R1's FA00 interface. Next, let's wrap up this lab by looking at the actual configuration of the IPv6 addresses, as well as a few show commands. First, we need to get into configuration mode, and then, using the IPv6 unicast-routing command, we need to enable IPv6 on this router. Without this command, you can't add IPv6 addresses to the interfaces, and the router won't route any IPv6 traffic. Next, let's move over to interface FA0/0 configuration mode, where we can configure the IP address for that interface, specifically the IPv6 address. So we use the IPv6 address command. So I'm going to copy and paste briefly, and there's the IPv6 address and prefix that we just talked about, and press enter. And now FA0/0 is ready to forward and receive IPv6 packets. Similarly, let's move over to the serial interface and then give it an IPv6 address command. So now this interface also has an IPv6 address. Notice the 4th octet in particular, its value is 112, which is a reminder that we're using subnet 112 on the serial link. And earlier we saw the 4th quartet had a value of 11, which is a reminder that it's subnet 11 on the FA0/0 interface. Next, let's take a look at a few show commands by getting out of configuration mode first. And then let's start with the show running config command. If we browse down just a tad, you'll see there's interface FA0/0, both with the IP address command for the IP version 4 address and the IPv6 address command with the IP version 6 address. Notice that the router has changed the address that I typed in. It had lots of extra zeros that could have been abbreviated, but now we see the shorter version of the command. Notice the 2 colons near the end of the address, as well as the last octet, instead of being 0001, is simply a 1. Next, let's take a look at the show IPv6 interface command. And then we'll put the FA0/0 parameter at the end to specifically look at that interface. Now, the show interfaces command without the IPv6 parameter just shows the IP version 4 address. To see the IP version 6 address, you need this command with the IPv6 parameter right after the show command. Now, if you look down a little bit, you can see the IP address we just configured, 2233:0, etc. And it's been abbreviated somewhat from the configuration command, just like you saw in the output of the show run command. Now, there's a lot of other information listed there as well. For instance, there's several multicast addresses that this particular router interface has joined. And there's also a link local address that begins with FoxEasy80 that you see up toward the top. One other important tidbit of information near the top is that this command lists the subnet number as well as the IP address. Notice here we have the subnet number with the /64 prefix length listed on the end. Finally, let's take a look at the output of one more command, the show IPv6 interface brief command. This command is very similar to the IPv4 command of show IP interface brief, but in this case, of course, we're going to see IP version 6 information. Note here we've got interface FA0/0 listed with the same IPv6 address we just saw in the output of the show interface command. Additionally, if you look a little further down, you see interface serial 0/0/1 with the IPv6 address there. That's the same address that was configured in configuration mode, however, it's also been abbreviated. And as a final show command, let's take a brief look at the show IPv6 route connected command. The show IPv6 route command without the connected keyword would show all IP version 6 routes, but of course if you use the connected parameter, it's only going to show the 2 connected routes on this router. Notice there we have a route that's listed off of FA00 and another that's listed off serial 0/0/1. In particular, look at the 4th quartet of those subnets. The output lists subnet 11 off of interface FA0/0 and subnet 112 off of interface serial 0/0/1. This concludes IC&D2 Lab 8. By viewing this lab, you've learned how to better describe the general format of IPv6 global unicast addresses. You've learned how to describe the similarities between IP version 4 and IP version 6 subnetting, and you've seen how to configure IP version 6 addresses on Cisco routers.